alpha cross r minus the omega squared times r. Okay. So the acceleration of point A, even though we don't know what it is, we're told it accelerates to the right, and so our acceleration of point A will be something like this. Okay. If this thing is rotating with angular acceleration clockwise, then we're going to get a tangential acceleration that's going to be, say, something like that. So this would be our acceleration of point C in the tangential direction, and then we're going to get a normal acceleration of point C, something like that, right? And so this is what we got to figure out, okay? But when we add these all together, okay, for instance, if we add these two together, we're going to get an acceleration of point C relative to B. That would look like this. So this would be our acceleration of point C relative to B, okay, or relative to A. I guess that's an A there. Okay. And then we're told that acceleration of C is equal to acceleration of A plus the acceleration of C with respect to A. So if I take these together now, I've got the acceleration of A like this, the acceleration of C with respect to A okay. And our equation says if we add these two together, okay, let's see, I've got to add it together, J equals C. So I haven't drawn that well. Okay, I got to draw a tip to tail, we're going to add them together. Okay, so this would more be the acceleration of C with respect to A, like this, so that we're adding them together. And then this here would be the acceleration of C. So this is the acceleration of C with respect to A, which was the same as this, and this is the acceleration of A. And this is what we're told, this, the magnitude of this side of our triangle, is equal to the 14. Okay. Now, we don't know the magnitude of each of these parts, and that's what we're going to have to figure out. Okay. But in general, that's what we need to do. Okay. The acceleration of C relative to A has a tangential and a normal component. Well, we can add those together, and then add that to the acceleration of A, and that will give us the acceleration of C. We can do the same thing with velocity. Velocity is a little bit easier, right? We can make velocity B, or blue. Okay, our velocity equation is this one here. But so it's our velocity of C is equal to our velocity of A plus our velocity of C with respect to A. So our velocity of C will also be to the right. Okay. Well, we know our velocity of C with respect to A, that's going to be tangential. So let me just put it out here somewhere. Okay. So when we take these two, okay, we're going to get a nice right triangle, because our velocity of C is going to be like this. Our velocity of A with respect to C, whoops, put it in the wrong place again. Velocity of A with respect to C, C with respect to A, that's good. Okay. And so this plus this, okay, this is our velocity of C. Okay. And the magnitude of this has to be equal to 2 meters per second. So a little picture of what we got going on. We don't know the magnitude, we do know the directions. So the velocity will be the easier one, so let's attack that one first, and then come back for the other one.
Is the bottom arrow?
Excuse me?
Do those both say V of C?
This says V of C, this says V of C.
What is the one V of A?
In blue or red?
It's in the blue, the diagonal one on the triangle.
Oh, this is V of C. Oh. Let's see. This should be A, shouldn't it?
Yeah.
Because A is in the middle. Good. Okay. Is that better? Yeah, I think that's better. Okay, good. I had too many C's. Okay, so let's go ahead and do this. Okay, so we'll do the velocity part. We know the velocity of A. It's going to the right because we were told that, and so it's just going to be equal to R times omega in the I direction. The velocity of C with respect to A is equal to omega cross R. I'm going to use lowercase r here as a vector, okay? And it's a cross product. In this case, because we're rotating this way, okay, the vector omega is into the board, and the r is in this direction, okay? So if we go into the board, curl our fingers in the r direction, our thumb points up. Okay? Which, if this thing's rotating this way, the velocity of point C should be in that direction. Okay? So just kind of proving that. Okay? And so we're going to have omega and r, the value of lowercase r is equal to the uppercase r. And like we said, in the positive j direction. If we wanted to do it as a cross product, we could take omega is in the negative k direction, and r is in the negative I direction. Okay. And so you have a negative negative, that gives you a positive. K cross I is a positive j, and so that's another way of proving it, or showing it. So what we've got now is we've got this term here and this term here. So we've got our velocity of C is equal to R times omega in the I direction, plus R times omega in the J direction. Okay. And we're told that the velocity of C is equal to, the magnitude of the velocity of C is equal to 2. Well, we've got everything we need here, okay? The magnitude, this is just a triangle. We got a component in the x direction, a component in the y direction. Okay, so the magnitude of this is just equal to r times omega squared plus r times omega squared